For a parabola ax square plus bx plus c, we don't know the complete parabola, but what we know is it has a vertex at 4, 2 and the variable a would be from 1 to 3, a number which lies between 1 and 3. Then the difference between the extreme values of a into b into c is required. Now let's consider the parabola first. Y is given to be ax square plus bx plus c. Now what is vertex of this parabola? Yes, for this the vertex is given by minus b by 2a comma 4ac minus b square by 4a, but this vertex is given as 4, 2. Now when we compare the x coordinates on both x coordinates and y coordinates on both sides, what do we get? Two relations on ABC, which gives b as minus 8a, and another relation that gives is c minus of b square by 4a is 2, or can we rewrite the second expression as c value is 2 plus b square by 4a. Now again, using the first relation in this, we can also rewrite c value as 2 plus, what is b square? 64a square by 4a, or simplifying this would be 2 plus 16a. Now we got the c value expressed in terms of a as well as b value expressed in terms of a. Now the product which we want, let us treat it as delta, as a into b into c. We need the difference of extreme values of this, but b and c are no more new variables. We have b in terms of a and c in terms of a. So when we express this, a times b is minus 8a into c is 2 plus 16a. So we are able to express the delta as a pure function of a, which is delta equal to minus 16 times a square plus 8a cube. Now how do we identify the extreme values of delta? Yes, we need the derivative of this delta with respect to a. Now when we calculate d delta by dA, how much is this value? Minus 16 times 2a plus 24a square. As a is positive, 2a is positive and 24a square is positive. So can we write this expression is always negative for all a belongs to the given interval 1 to 3. Now what do we mean by d delta by dA is negative for all a belongs to 1 to 3? Yes, delta is a decreasing function on 1 to 3. Now when delta is decreasing on 1 to 3, what can you say about the maximum and minimum? Therefore delta's maximum is the value of delta at a equal to 1. What is the value of delta at a equal to 1? That would be minus 16 times 1 square plus 8 times 1 cube, that is 8 plus 1 9 into minus 16, that is minus 144. And similarly the delta's minimum would be at the lower end, that is value of delta at a equal to 3. So how much will be the delta value when a is 3? It is minus 16 times 3 square plus 8 times 3 cube, which is minus 3600. Now we know both delta maximum and delta's minimum, that is the product ABC's maximum and minimum. So what is the difference of extremums of a into b into c? It would be minus 144 minus of minus 3600, which is 3456. Which option is it satisfying? The option C, which says the difference between the extreme value is 3456. No need of finding the first derivative and second derivative to identify the maximum and minimum. Clearly on 1 to 3, as the function is decreasing, the maximum would be at the lower end and the minimum would be at the upper end, right?